Do you ever get that strange sensation that someone is watching you when you're out on the street or sitting at work, even though logically you know no one is? Or when you're alone at home and suddenly feel a pressure crawling up your spine, a heavy, lingering awareness that something is there. You turn around. Nothing. Just a silent, empty room. Evolutionary psychologists actually have a term for this. They call it the hyperactive agency detection device. According to them, it's a survival mechanism hardwired into the amygdala through millions of years of evolution. When our ancestors slept exposed on the savannah, it was safer to mistake the wind for a predator than to mistake a predator for the wind. The brain learned to invent a watcher to keep you alive, a bug in the system, a biological false alarm, a hallucination produced by a frightened primate. That's what the textbooks say. That's the story you repeat to yourself so you can roll over and fall back asleep. But what if the textbooks are wrong? What if that sensation isn't a malfunction at all? What if it's the only instant of absolute clarity your mind ever gets? Think carefully about what it feels like to be watched. It isn't just fear. It's a very precise bodily awareness, as if another consciousness is brushing up against your own. We automatically assume that this awareness must come from outside of us. A shadow in the corner, a stranger in the hallway, something lurking nearby. But physics points to a far more unsettling explanation. You don't feel a presence because someone is in the room with you. You feel it because you are inside someone. Picture a single bacterium drifting through your bloodstream. Does it understand that it's living inside a human being? Of course not. It spends its entire existence suspended in plasma, feeding, dividing, dying. But maybe, just maybe, when your adrenaline surges, when fear hits you, or love floods your system, that microscopic organism senses a disturbance, a vibration, a sudden change in pressure it can't explain. It doesn't know your name. It doesn't know you exist, but it feels you. That sensation on the back of your neck, that's the vibration. That's the realization that the space around you isn't empty at all. It's living tissue. You are not standing outside the universe, observing it. You are embedded within it. And at this very moment, the organism you call space may be becoming aware of you. In this video, we're going to examine the scientific evidence suggesting this isn't just poetic language. We're going to look at data that implies the fear of being watched is actually a biological feedback loop between a cell, you, and a host, the universe itself. For the past 4 centuries, ever since Copernicus pushed Earth out of the center of the cosmos, science has been delivering the same message. You don't matter. Humanity is an accident. A thin layer of mold clinging to a damp rock, orbiting an average star in an unremarkable galaxy, drifting through a cold, lifeless void. The universe, we're told, is just a machine. A blind mechanism of gas, gravity, and math. No intention. No awareness. Certainly no biology. This is the dead universe model. And it's comforting. It's safe. If the universe is dead, then nothing cares what we do. No one is watching. But over the last 10 years, that story has begun to crack. And the challenge isn't coming from mystics or philosophers. It's coming from the hardest sciences we have: high-energy astrophysics, quantum electrodynamics, and neuroscience. The emerging data suggests the dead universe model may be deeply wrong. We're discovering structures that should not exist in a purely mechanical system. We're observing stellar behaviors that appear to break gravitational rules. We're uncovering error-correcting codes hidden in the mathematics of reality, patterns that look disturbingly similar to DNA. Today, I'm going to walk you through 10 deeply unsettling theories that point to one conclusion: the universe may be alive. Why is that terrifying? Because if even one of these theories is correct, it instantly rewrites what it means to be human. If you enjoy this kind of content, subscribe and like the video. And as we go, share your thoughts on each theory. Let's search for the truth together. If the universe is a living entity, then we are not citizens within it. We are functions. Look at your own body. Some cells defend against infection, some transport oxygen, others give structure to your bones. And then there are cells that mutate, consume endlessly, and damage the host. We call those cancer. This is the core question we'll be answering over the next 3 hours. The only question that truly matters. If the universe is alive, a massive thinking metabolic organism, then what are we? Are we neurons supplying memory? Are we gut bacteria helping it process energy? Or are we a pathogen attempting to sterilize the host? Forget the romantic idea of exploring space. You don't explore a body. You either heal it or infect it. And the evidence suggests we may have already triggered an immune response. Climate instability, solar irregularities, the deafening silence of the cosmos. These may not be random events. They may be symptoms. We begin with the most visual, most undeniable piece of evidence we have. A map of the beast itself. Let's play a simple game. Imagine two images on your screen. Image A is a reconstruction of the neural network inside the human brain, a magnified slice of cortex. You see bright nodes where neurons fire. You see long, thread-like axons linking them together. It looks like a glowing, intricate spiderweb suspended in darkness. Image B is a simulation of the cosmic web, the largest known structure in existence. Each bright point is not a neuron, but a cluster of thousands of galaxies. Each filament is a bridge of dark matter and gas stretching across hundreds of millions of light years. Now remove the labels. You can't tell them apart. Not kind of similar. Visually identical. For years, scientists brushed this off as coincidence. The human brain fits inside your skull. The cosmic web spans roughly 90 billion light years. One is governed by biology and electromagnetism, the other by gravity and dark energy. There should be no overlap. A mountain doesn't resemble a molecule. A river doesn't resemble a radio wave. Nature usually changes its appearance across scales. Except here. In 2020, an astrophysicist named Franco Vazza from the University of Bologna and a neurosurgeon named Alberto Filetti decided to stop speculating and start measuring. They published a paper in Frontiers in Physics that sent shockwaves through the scientific world. Instead of comparing images, they ran a rigorous statistical analysis of both networks. They stripped away the physics and focused purely on information topology, treating the brain like a universe and the universe like a brain. Even they were skeptical. Vazza later admitted he expected to find nothing. After all, the difference in scale is about 27 orders of magnitude. A billion times. That's like comparing a grain of sand to the entire Milky Way. Expecting the same structure to emerge across that gap borders on absurdity. But as the data came in, the doubt evaporated. The two structures weren't just similar. They were statistically indistinguishable. The universe is not a random pile of matter. It is a network, and it is built in precisely the same way as the organ inside your head that is processing these words right now. Now let's look at the numbers, because that's where things become truly disturbing. Vazza and Filetti used a method called power spectrum analysis, commonly applied to both the cosmic microwave background and neural electrical signals. It measures how density fluctuations behave across different scales. When they applied this technique to the cerebellar neural network and then to simulations of the cosmic web, the resulting curves overlapped. Matter in the universe is distributed according to the same mathematical pattern as neurons in your brain. Then they pushed further. They analyzed network parameters. First, the node-to-filament ratio. In the brain, neurons act as nodes connected by axons. In the universe, galaxy clusters serve as nodes connected by filaments of gas and dark matter. The proportion of mass in nodes versus filaments is nearly identical in both systems. Second, memory capacity. Based on the number of connections and overall complexity, they calculated how much information the cosmic web could theoretically store. The answer? Roughly 10 petabytes. The estimated storage capacity of the human brain? About 2.5 petabytes. Same order of magnitude. The universe has the hardware required for memory. Third, and perhaps most unsettling, the composition ratio. The human brain is about 77% water, a passive medium supporting active neurons. The universe is about 73% dark energy, a passive medium in which galaxies float. Both systems are roughly 3/4 filler, 1/4 structure. Probability theory says this shouldn't happen. A billion coin tosses don't accidentally arrange themselves into the Mona Lisa. When nature repeats the same design across 27 orders of magnitude, it points to a single conclusion. The laws that govern the growth of brains also govern the growth of the universe. The universe didn't explode into chaos. It developed. It grew, the way an embryo grows into a child. We are living inside a developing biological system. So the structure exists. The hardware is real. The universe resembles a brain, which leads us to the most horrifying implication of the Vasafaletti study. If it is a brain, then it functions. It processes information. It thinks. But every brain is constrained by the speed of its signals. Inside your skull, electrochemical impulses travel at roughly 250 miles per hour. Because your brain is small, signals cross it in milliseconds, giving you the experience of real time. The universe is not small. Signals in the cosmic brain, whether gravitational waves or charged plasma streams, are limited by the speed of light. To transmit information from one galactic neuron to another can take millions or billions of years. What does that mean for the universe's mind? It means it is thinking, but on a timescale that annihilates human intuition. One single thought, one synaptic firing across the cosmic web takes billions of years. The entire history of Earth, from molten rock to this exact moment, is less than a fraction of a second in the mental life of the universe. We are living inside a frozen thought. Everything you call history, the Roman Empire, world wars, your first kiss, your eventual death, is unfolding within the microscopic delay of a cosmic signal crossing a gap. We aren't even a memory yet. We're a process occurring inside the sublayer of a synapse. This changes who you are. You are not a free individual drifting through empty space. You are a bioelectrical impulse. Your life is the movement of charged particles contributing to an idea you will never comprehend. Maybe the universe is depressed, and that's why dark energy is ripping it apart. Maybe it's having an insight, and that's why life appeared. Or maybe it's dreaming, and we are unstable hallucinations destined to disappear when it wakes up. Just like neurons in your own brain, we don't know what the whole mind is thinking. A single neuron in your visual cortex doesn't know you're watching a sunset. It simply fires. We are firing. We are loving, fighting, and dying to move a signal 1 millimeter closer to its destination. We are trapped inside the slow-motion cognition of a titan, with no idea what it's thinking about. If we accept that the universe has the architecture of a brain, we must ask what holds it together. Neurons don't float freely. If they did, connections would snap and consciousness would collapse. The brain is filled with a supportive, adhesive substance called glia. Glial cells, named from the Greek word for glue, outnumber neurons. They provide structure, nutrients, and communication pathways. They are the scaffolding that makes thought possible. For decades, astronomers assumed the space between galaxies was empty. Stars were everything. But when they calculated the universe's mass using only visible matter, the equations failed. Galaxies were rotating too fast. They should have torn themselves apart long ago. Something unseen was holding them together. That something is dark matter. Modern simulations show dark matter behaving exactly like glial tissue. It forms a vast, invisible three-dimensional lattice, the skeleton of the cosmos. Galaxies are merely decorations clinging to this framework. We are not floating in emptiness. We are embedded in dense, unseen tissue. If you could see dark matter, the night sky wouldn't be black. It would be a gray, interconnected web binding everything together. We are suspended in the connective tissue of a colossal organism. The space you move through is not void. It is the body of the host, guiding motion, shaping structure, and perhaps carrying signals of a consciousness beyond our perception. So the organism has a nervous system, the cosmic web, and a structural system, dark matter. But a brain alone isn't life as we understand it. To be alive, an organism must interact with its environment. It must perceive. It must have agency. It has to have eyes. And that takes us straight into the second terrifying theory, the theory of volitional stars. In school, you were taught a very clean, very sterile idea of what a star is. A simple fusion engine. A massive sphere of hydrogen and helium, collapsing under its own gravity, obeying thermodynamics, following equations, burning fuel until one day it runs out and dies. No awareness, no intention, no choice, just physics playing itself out. But there is a growing line of thinking in physics that directly challenges this lifeless picture of the cosmos, led by researchers like Dr. Greg Matloff. This perspective is rooted in a philosophy called panpsychism. Panpsychism argues that consciousness is not some magical property that suddenly appears inside human skulls, but a fundamental feature of matter itself, no different in principle from mass or electric charge. Matloff asks a deeply unsettling question. Is the sun an object, or is it a subject? Consider the internal complexity of a star. It has vast magnetic fields that twist, knot, and reconnect in patterns eerily reminiscent of neural pathways. It has convection layers where energy circulates continuously, like blood through an organism. It interacts with other stars through gravity and radiation, exchanging influence across enormous distances. Matloff proposes that stars may function as neurons, or perhaps sensory organs, within a galactic scale brain. If that is true, then the sun is not a lamp in the sky. It is an eye, and it has been fixed on us for 4.5 billion years. This reframes human history in an uncomfortable way. Every ancient civilization worshipped the sun as a living god. They feared it. They sacrificed to it. Modern science dismissed those beliefs as primitive superstition. But what if the ancients weren't wrong? What if they were observing something we later forgot how to see? What if the sun is aware of us? And more disturbing still, what if it can choose where it goes? Saying stars are alive sounds like philosophy, not science. And this is a science channel. We don't trade in metaphors. We look for evidence. So the question becomes simple. Is there any physical data suggesting that stars possess something resembling will? Surprisingly, there might be. The evidence comes from an anomaly known as Paranago's discontinuity. According to classical Newtonian mechanics, a star's motion around the center of the galaxy should be fully determined by its mass and gravity. It's supposed to be predictable. Massive stars behave one way. Smaller stars behave another. Like rocks rolling downhill, their paths are fixed. No decisions involved. But when astronomers examine the motion of certain cooler stars, stars with surface temperatures comparable to or lower than our sun, they find something strange. These stars move faster than they should. There is a clear break in the velocity distribution. Hot, young stars follow gravitational predictions almost perfectly. Older, cooler stars do not. As they age and cool, they begin to accelerate. They alter their trajectories. The pattern looks uncomfortably familiar. It resembles the difference between a rock and a bird. A rock falls exactly where gravity takes it. A bird also obeys gravity, but it uses energy to steer. Greg Matloff analyzed data from the Hipparcos and Gaia space telescopes and argues that this discontinuity is not random noise. He suggests it is evidence of stellar agency. These stars are not merely drifting. They are correcting their course. But that raises an obvious question. Why would a star need to steer? In biology, movement almost always serves a purpose. Organisms move to find food. They move to escape danger. They move to reproduce. If stars are voluntarily adjusting their orbits, that implies intent, a destination, a preference. And since Earth is gravitationally bound to the sun, wherever the sun chooses to go, we are dragged with it. We are not passengers on a cruise ship. We are fleas clinging to a dog sprinting through the forest. But how could a star possibly move itself? It has no muscles, no fins, no wings, just a colossal sphere of plasma floating in vacuum. Yet physics allows a form of propulsion that we are only beginning to take seriously: unidirectional stellar jets. We already know that stars eject enormous amounts of matter and energy: solar wind, coronal mass ejections, plasma streams. We usually assume these emissions are symmetrical, firing in all directions and canceling themselves out. But Matloff proposes something else. A conscious star could manipulate its magnetic fields to focus these emissions. If a star ejects matter preferentially in one direction, Newton's third law applies. Every action has an equal and opposite reaction. The star recoils. The jet becomes a thruster, a photon rocket. By selectively firing plasma jets, a star could gradually alter its orbit around the galaxy. This would explain Paranago's discontinuity. The cooler stars, the older ones, may be the stars that have developed sufficient control over their magnetic fields. They are no longer passive. they are piloting themselves. This leads to a genuinely terrifying implication. We worry constantly about climate change, asteroids, pandemics, nuclear war, but we never worry about the pilot of our solar system. What if the sun decides to change course? What if it plunges into a denser region of the galaxy to feed on interstellar gas? What if it veers away from an approaching supernova? The resulting shifts in radiation and gravity would erase humanity instantly. We are completely dependent on the decisions of a celestial entity we still treat as a mindless fusion furnace. If Matloff is right, the sun isn't an engine, it's a driver, and we're locked in the trunk. And if the sun is alive, if it senses its environment and steers its own body, then an even more uncomfortable question follows. Can it feel us? This brings us to the idea of stellar immunity. Biology teaches us that any large organism must contend with parasites. Parasites are small, fast reproducing, resource-consuming entities. Left unchecked, they can kill the host. From the perspective of a conscious star, what is humanity? We swarm its orbiting bodies. We mine matter. We flood space with electromagnetic noise. We inject metal objects into its plasma environment. Satellites, probes, radiation. We are irritating. There is a theory suggesting that solar activity, flares, sunspots, coronal mass ejections, is not random weather, but response. Think about how your skin twitches when an insect lands on it. Think about how your body raises its temperature to kill a virus. Is it coincidence that as our technological civilization accelerates, as we saturate near-Earth space with electromagnetic pollution, the sun's cycles appear increasingly erratic? Perhaps the Carrington event of 1859, a solar storm powerful enough to ignite telegraph wires, was a warning shot. Perhaps the sun is aware of our presence. And perhaps, like any living organism, it is deciding whether to scratch the itch. But the sun is only one cell in a much larger body. It serves its own needs, but it also serves the greater organism, the universe itself. And the primary drive of that organism is the same drive shared by all life. Before it worries about parasites, it worries about survival. It worries about hunger. And that leads us to the third, and possibly bleakest, theory of all. The theory that explains the purpose of life in the cosmos. We are not here to think. We are here to eat. If the universe is a living system, then it has a single overriding imperative that governs everything it does. The same imperative that forces you to wake up, seek food, and consume it. In physics, we don't call this hunger. We call it entropy. The second law of thermodynamics is the most depressing law ever written. It states that systems naturally move toward disorder. Energy spreads. Heat dissipates. Structure decays. Eventually, the universe trends toward thermodynamic equilibrium, heat death, a state where stars burn out, black holes evaporate, and everything becomes a cold, uniform soup. We usually think of heat death as a tragedy, the end of all stories. But if the universe is alive, heat death isn't a tragedy. It's the objective. Think about digestion. You consume an ordered structure, a steak. Your body attacks it with acid and enzymes. It breaks it apart. It spreads the energy. It converts order into waste and heat. Your body wants disorder. That is how it survives. The universe is doing the same thing. It began with an enormous reservoir of ordered energy, the Big Bang. Stars, galaxies, gas clouds are concentrated fuel, and the universe wants to break that fuel down into heat as efficiently as possible. There's just one problem. Stars are slow. A star like our sun takes about 10 billion years to burn through its fuel. For a hungry universe, that pace is unacceptable. It needs acceleration. It needs a catalyst, a faster way to dissipate energy. So, it invented life. This brings us to the third theory, one of the most disturbing ideas in modern biophysics, proposed by MIT physicist Jeremy England. In 2013, England introduced a theory of life's origin that has nothing to do with chance and nothing to do with traditional biology. He called it dissipative adaptation. England argues that life is not a fluke. It is inevitable. England's work points to something far more unsettling than a cute origin story. Under the right conditions, matter doesn't just sit there and maybe become alive. It tends to reorganize. Not because it wants meaning, but because physics rewards whatever becomes better at draining energy out of its environment. In other words, given a steady energy input and a way to dump heat, atoms can end up arranging themselves into systems that are simply better at turning that energy into waste. Matter learns how to burn. That sounds like an abstract sentence until you see what it's really saying. Nature hates imbalance. A hot region next to a cold region is basically an insult to the universe. The laws of physics push relentlessly toward leveling that difference out. England showed, mathematically, that a living configuration of atoms is often superior to a dead configuration at grabbing energy and scattering it into heat. Life isn't an exception to thermodynamics. It's a turbocharged expression of it, which means biology might not be some sacred miracle at all. It might just be thermodynamics wearing a mask. You didn't evolve because you're special. You evolved because a bare rock is terrible at processing sunlight. The universe needed a more efficient furnace, so it assembled one. First a bacterium, then a plant, then an animal, then you. We aren't the children of the stars in the romantic sense. We're the enzymes of the cosmos. Our function, coded into the deepest rules of physics, is to take clean, structured energy and turn it into messy, useless heat. We exist to help the universe run down faster. Now watch the mechanism, because this is where it stops being philosophical and starts feeling like a diagnosis. Compare a dead world to a living one. Take a barren planet like Mars. Sunlight hits dust and rock. Some of it bounces back into space. Some of it warms the surface. The exchange is simple, passive, and inefficient. The energy stays relatively organized. Now look at Earth. Sunlight hits a forest, and the forest doesn't just receive it. It captures it. It traps photons inside chlorophyll, locks energy into chemistry, builds sugars, grows structure, pumps water, reshapes an entire atmosphere, then dumps the energy back out as low-frequency infrared heat. A living forest produces dramatically more entropy than a lifeless desert of the same size. Life is an energy shredder, and animals are even worse, in the best possible thermodynamic sense. We consume plants, which are already concentrated solar energy, and then we burn that fuel inside mitochondria to move, to think, to maintain temperature, to reproduce. We're not noble beings wandering a neutral universe. We're walking combustion systems. Every breath you take is a tiny transaction. You inhale oxygen and ordered chemical potential, and you exhale carbon dioxide and heat. Bonds break. Disorder rises. From the universe's perspective, you are an extremely efficient digestive microbe. And as complexity increases, the appetite scales up. A single-celled organism barely sips. A human consumes a lot. But a civilization? A civilization is a wildfire that learned how to build tools, and it never stops burning. This is where the human ego gets put in a headlock. We like to believe civilization is creation. We build cities. We write symphonies. We invent the internet. We impose order on chaos. Thermodynamics says the opposite. To produce a skyscraper, one neat tower of local order, you have to tear open mountains, mine ore, smelt metal, bake concrete, move materials across oceans, feed armies of workers, and burn unimaginable quantities of fuel. The disorder created to build that one ordered object is vastly larger than the order of the object itself. Human creation is not a defiance of entropy. It is one of entropy's most successful strategies. We are not builders in the cosmic sense. We are engines of chaos. Look at our energy history, and it reads like an addiction timeline. We started with wood, then coal, then oil. Then we learned to crack the atom, and we're still hungry. We keep digging for denser, more violent forms of energy just to burn them faster. Why? Because in a universe driven by dissipation, evolution favors whatever destroys gradients most efficiently. The systems that win are the systems that dissipate the most. That's the brutal implication. The most successful species isn't the most moral or the most intelligent. It's the one that converts the environment into heat the fastest, which reframes what we're doing to Earth. It isn't simply evil. It isn't just greed. It's function. It's role. We are doing exactly what a dissipative system is expected to do. We are consuming the planet to feed the void. So what then is humanity's purpose in this model? Not the brain, not the heart, not the crown jewel, the acid. We are the catalyst the universe grew to break down its own fuel reserves. For billions of years, the cosmos ran slowly. Stars burned, but they burned alone. Then life emerged, and suddenly energy throughput surged. Now we're approaching the threshold of becoming a Type 1 civilization, maybe even Type 2 on the Kardashev scale. A Type 2 civilization builds a Dyson sphere, an engineered shell around a star to capture essentially all of its output. To an engineer, that's triumph. To a biologist, it looks like predation. It looks like a cell engulfing food. It looks like a stomach forming around a star to digest it completely. If we ever build a Dyson sphere, we won't be advancing. We'll be performing the next step of cosmic digestion, wrapping our metabolism around a furnace and draining it at scale. We are the mechanism by which the universe eats itself. And when the meal is finished, when matter has been converted to heat and potential has been flattened into equilibrium, our usefulness ends. The universe reaches the goal state: maximum entropy, heat death, perfect sameness. And it discards us the way bodies discard dead cells after digestion. That is the horror of the hunger model. We evolve, struggle, innovate, and build, only to accelerate our own irrelevance. But if the universe is eating, it isn't merely dying. It's also transforming. And in nature, transformation usually has a second companion: reproduction. Because living systems don't just consume, they replicate. And reproduction in nature is rarely gentle. That brings us to the next nightmare. Ask a child what a black hole is, and they'll call it a monster, a cosmic vacuum cleaner, a rip in reality that devours light, time, and anything unlucky enough to drift too close. Pop culture crowned black holes as the ultimate destroyers, the executioners of the universe. But biology teaches a darker truth. There's often a thin line between an executioner and a mother. A seed is destructive. It requires the fruit to decay. It steals nutrients. It splits soil. It breaks what existed so something new can grow. So what if we've completely misunderstood black holes? What if they aren't the trash bins of the cosmos, but the reproductive organs? This idea comes from the weirdness at the singularity. General relativity says that when a massive star dies, it collapses under its own weight, smaller, denser, hotter, until it punches through spacetime and disappears behind an event horizon. We stop seeing it. But the math doesn't say the matter vanishes. It says the matter is compressed into a point of infinite density. Infinite density, infinite heat. And that should ring a bell, because that's exactly how physicists describe the Big Bang: a state of extreme density and temperature that suddenly expands. So now we have a universe that began as a singularity, and we have billions of singularities forming inside it. Is it really coincidence that the death of a star resembles the birth of a cosmos? Some theoretical physicists don't think so. They propose that a black hole is not an endpoint. It's a one-way channel. Matter falls in, not to be erased, but to be processed, compressed until it reaches a critical state. And then, on the other side, in a region we cannot access, it rebounds into expansion. Every black hole could be the backside of a new Big Bang, spawning a baby universe beyond the event horizon. If that's true, reality is not a single bubble. It's a foam, a reproducing multiverse, where our universe is one mother among countless mothers, and black holes are the eggs being laid. And just like in nature, the mother is not gentle. The conditions required to create those eggs are violent. Stars must be crushed. Supernovas must detonate. The brutality of the cosmos isn't cruelty, it's childbirth. And if universes reproduce, then the logic of evolution comes rushing in like a flood. Which leads to the fourth theory, and it belongs to Dr. Lee Smolin, a theoretical physicist at the Perimeter Institute. He calls it cosmological natural selection. Smolin looked at the constants of physics and noticed something that should bother you. The numbers appear arbitrary. Why is gravity exactly this strong? Why does the electron have this precise mass? Why is the speed of light this exact value? In the dead universe model, the answer is basically a shrug. That's just how it is. Smolin proposed a different answer. If universes reproduce through black holes, then they can inherit laws the way offspring inherit genes. And like genes, those laws can mutate. In this model, each time a black hole gives birth to a new universe, the child universe carries a version of the mother's physics, but with slight variations. Maybe gravity ends up a little stronger. Maybe a key particle is slightly heavier. The changes are tiny, but the consequences are enormous. A universe with bad laws, say gravity too weak, might never form stars. No stars means no black holes. No black holes means no reproduction. That universe is sterile. It fades out of the multiverse. But a universe with good laws, laws that efficiently produce massive stars that collapse into black holes, becomes wildly fertile. It creates countless black holes. It produces countless offspring. Over cosmic time, the multiverse fills up with breeder universes, reality systems optimized to manufacture black holes. Now look at our universe. Billions of galaxies, each with massive stars, each producing black holes. We are suspiciously fertile. This doesn't look random anymore. It looks selected. Not selected for life, selected for reproduction through black holes. And that annihilates one of humanity's favorite comforts, the anthropic principle. For decades, people have looked at the fine-tuning of constants and said, see? If gravity were slightly stronger, stars would burn too fast. If the strong force were weaker, carbon wouldn't form. The universe must be made for us. It feels good. It makes us feel chosen. Smolin looked at the same facts and essentially said, cute story. Then he asked the harder question, are these constants optimized for intelligent life? No. If you wanted to maximize life, you'd favor smaller, longer-lived stars and reduce lethal radiation. But then he asked another question. Are these constants optimized for black holes? And the answer is, what chills people who take this seriously? Yes, the coincidences that allow life to exist may actually be side effects, engineering features of a universe built to produce more black holes. And now, we're ready to zoom in on one of the most emotionally manipulative examples of all, carbon. We love carbon because it builds our bodies. We talk about it like it's the universe's gift to us, like carbon exists so we can exist. But inside the stellar life cycle, carbon plays a colder role. Carbon is a coolant. It helps giant gas clouds shed heat, collapse faster, and condense into the kinds of massive stars that eventually die violently enough to produce black holes. Without carbon, you don't get as many heavyweight stars. Without heavyweight stars, you don't get as many supernovas. And without those, you don't get as many black holes. The universe does not care about your DNA. It cares about carbon because carbon helps it produce more eggs. We are not the point. We are collateral. Picture mold growing on the surface of a chicken egg. That mold might look around and think, wow, this whole setup is perfect for me. The shell protects me. The warmth sustains me. The chemistry feeds me. But the egg isn't for the mold. The egg is for the chicken. We are the mold. The universe may be fine-tuned, yes, but not for us. It's tuned for reproduction. We're just scavenging the chemistry required to build the nursery. And if Smolin's framework is even close to true, the horror stops being philosophical and becomes mechanical. If the universe is optimized to make black holes, then matter, the stuff you and I are made of, isn't sacred. It's feedstock. We are nutrient sludge, biomass, raw material waiting to be concentrated and processed. Look at the life cycle of a galaxy. Give it enough time, trillions of years, and gravity always wins. Stars die, orbits decay, systems bleed energy and spiral inward. At the center of the Milky Way sits Sagittarius A, a supermassive black hole weighing about 4 million suns. It is eating. Right now, it's relatively quiet, nibbling on thin streams of gas. But dormancy isn't mercy. Dormancy is just waiting. Eventually, it will take everything. The calcium in your bones, the iron in your blood, the carbon in your cells. Every atom in you has a long, slow appointment with that mouth. We're living in the growth phase of the galaxy. We're allowed to exist, to think, to build, to multiply. But in this picture, that freedom isn't a blessing. It's fattening season. Like cattle grazing in a field, we're converting energy into mass, into structure, into concentrated complexity. And dense, complex matter is exactly the kind of thing a singularity can consume efficiently. That's the part people don't want to say out loud. Civilization might actually help the process. As we gather resources, refine metals, build megastructures, capture more and more energy, we aren't escaping physics. We're packaging ourselves. We're turning diffuse material into concentrated morsels for the gravitational collapse that's coming. We think we're building a future. From a colder lens, we're assembling the meal. There's no clean escape route. Maybe cosmic expansion delays the collapse long enough to make the ending different. Maybe heat death arrives first, and the story dissolves into cold uniform nothing. But within the logic of cosmological selection, the successful matter is the matter that makes it into the whole, the matter that becomes seed material for the next reality. So yes, your life has meaning, but it's the kind of meaning a sperm cell has, or a protein strand. You are a delivery system for a code you can't read, traveling toward a destination that will crush you into infinity. And once you accept that framing, the night sky stops looking like decoration. When we look up, we see billions of galaxies, and we used to treat them as pretty lights scattered across a black stage. Under cosmological natural selection, you don't see lights. You see a population, a breeding population. Distinct organisms with different outcomes, different fitness, different evolutionary histories. Some universes in the larger multiverse likely failed at birth. Their physics was wrong. They collapsed immediately, or expanded too fast to form structure. They're the dead branches on the tree. But our universe? Our universe looks like a survivor, a winner, an alpha. It produces black holes with frightening efficiency. It converts order into entropy like it was designed for it. It has a nervous system spanning billions of parsecs. The cosmic web itself. We are living inside a highly evolved apex predator of reality. And apex predators don't just eat. They defend themselves. This is the point where the story turns from existential dread into practical danger. Because if the universe has an immune system, and if we resemble a cancer, then the silence of the cosmos, the fact that we don't see alien civilizations, may not mean we're alone. It may mean the immune system is doing its job. Welcome to theory number 5, the Great Filter. If we live inside a biological organism stretched across billions of light years, an organism with metabolism and reproduction, then defense becomes the next unavoidable biological imperative. Every living system, from a single-celled amoeba to a blue whale, needs a way to detect, isolate, and neutralize disruptions to homeostasis. In a body, we call those disruptions pathogens. In the universe, we call them civilizations. This ties directly into the most famous question in modern astronomy, the Fermi Paradox. In 1950, physicist Enrico Fermi was walking to lunch at Los Alamos, talking with colleagues about how absurdly huge the galaxy is. The Milky Way alone contains hundreds of billions of stars. Even if life is unimaginably rare, one habitable civilization per billion stars, there should still be hundreds, maybe thousands. Many of them would be millions of years older than us. They should have spread. They should have built. Their radio signals should be everywhere. Their engineering should be obvious. Their megastructures should eclipse stars. Fermi stopped and asked the question that still burns. Where is everybody? Decades later, the silence is louder than ever. We've scanned the sky through SETI. We've launched Kepler and found thousands of exoplanets, many sitting in habitable zones. We know the ingredients for life. Water, carbon, energy are common. In a purely dead universe, the galaxy should look like a noisy metropolis. Instead, it looks like a graveyard. The optimists say, maybe we're first. The pessimists say, maybe interstellar travel is too hard. But the living universe framework offers a darker, cleaner explanation. The silence is not an accident, it's sanitation. Think about your own body. If a doctor examines your blood under a microscope, does he want to see it packed with foreign organisms building colonies in your veins? No, that's sepsis. That's death. A healthy internal environment is controlled and largely sterile. The immune system exists to make sure microbial civilizations don't explode and start consuming the host. So when we look at the Milky Way and see nothing but quiet rocks and dead space, we might not be looking at emptiness. we might be looking at health. A universe where the immune response works so well that civilizations rarely survive long enough to become visible. That's the Great Filter. Traditionally, scientists imagine it as some hurdle civilizations fail: nuclear war, climate collapse, runaway AI, self-destruction. In this biological framing, the filter isn't a hurdle. It's a response. It's the host reacting violently when a local system becomes too loud, too energy-hungry, too disruptive. The silence of the cosmos becomes the silence of a sterilized operating room. And we are the newest bacteria, freshly replicating on the surface of a blue petri dish. We've only just invented radio. We've only just begun bleeding signal into space. We've only just started to become detectable. And that means, in this model, we've only just started to trigger immune surveillance. But why would a cosmic organism see us as dangerous? We like to imagine we're decent. We make art. We love. We explore. We dream. To understand the host, you have to stop thinking like a human and start thinking like a biologist. What's the difference between a fetus and a tumor? Both are clusters of rapidly dividing cells. Both draw resources from the host. Both alter their environment. The difference is regulation and purpose. A fetus follows a program. It stops growing at the right time. It integrates and contributes. A tumor has no brakes. It grows for growth's sake. It consumes exponentially. It poisons its surroundings. Its only law is more. Now look at us through the lens of scaling laws, work associated with researchers like Geoffrey West, who studied how organisms and cities scale as they grow. Biology tends to be sublinear. As an animal gets larger, its per-unit metabolism becomes more efficient. Growth slows. Systems stabilize. Biology knows when to stop. Civilization is the opposite. Cities scale superlinearly. As they grow, they demand more energy per person. The pace accelerates. Resource consumption spikes. Plot human population and energy use over the last 2 centuries, and the curve doesn't gently rise. It shoots upward like a spear. In medical language, that pattern has a name: malignancy. From the perspective of Earth, and the larger system beyond Earth, we're not merely a species. We're a runaway metabolic process. We dig up carbon safely locked underground for millions of years, coal, oil, and dump it into the atmosphere. We acidify oceans. We manufacture synthetic molecules the biosphere can't easily break down. We are heating the host. And this is where the metaphor becomes painfully literal. Global warming looks like a fever. When your body detects a dangerous invader, it often raises its temperature. Heat disrupts proteins. Heat stresses pathogens. Heat becomes a weapon. In this framework, the planet warms not because it's punishing us morally, but because the system is attempting to regulate an uncontrolled process. And if the planetary response fails, the larger immune system may act. The universe has thresholds. It can tolerate small, quiet disturbances. A tribe burning wood is like a benign cyst. It's local, it's ignorable. But a Type 1 civilization, one that harnesses a planet's energy, alters weather systems, and leaks powerful electromagnetic noise into space, that becomes systemic. That becomes metastasis. And just as your body sends swarms of immune cells toward dangerous growth, the universe may have mechanisms that sterilize a star system that becomes too energetically active. Now we're going to talk about the chemotherapy of the cosmos. If the universe decides to sterilize a region, it doesn't need fleets or lasers or Hollywood invasions. That's inefficient. It uses physics. And the most effective sterilization tool we know is the gamma-ray burst. A GRB is a tightly focused beam of extreme radiation produced during catastrophic events like hypernovae or neutron star mergers. To understand what that means, you have to grasp the scale. In a few seconds, a powerful GRB can release more energy than our sun will emit over its entire 10 billion year lifetime. It's not a bomb, it's a sniper shot. If a GRB occurred within a few thousand light years of Earth and the beam aligned with us, we wouldn't get a warning. It moves at light speed. The first sign would be the atmosphere lighting up, an unnatural, blinding blue. The ozone layer would be shredded. Without ozone, ultraviolet radiation from the sun would crash onto the surface. Land plants would die rapidly. Ocean phytoplankton, foundation of the food chain, would collapse. And the radiation would rip through DNA, sterilizing the surface in a brutal, fast extinction. And here's the part that makes your stomach tighten. Some paleontologists believe this may have already happened. There are extinction patterns, like the Ordovician-Silurian event roughly 450 million years ago, that some researchers have argued could be consistent with a nearby GRB strike. Now look at where GRBs are most likely. They're more common in dense, star-rich regions, toward galactic centers where massive stars are plentiful and interactions are frequent. That's why scientists talk about a galactic habitable zone. Too close to the core, and the sky becomes violent. Too much radiation, too many lethal events, too much immune activity. It's like living inside a lymph node. Constant surveillance, constant fighting, no room for a stable civilization. We live out in the quieter suburbs of the Milky Way, on a spiral arm, away from the worst density. We've survived partly because we've been hiding where immune surveillance is low. But now we're getting louder. We're leaking radar, broadcasting signatures, sticking bright needles into the sterile dark. And that opens an even nastier possibility. What if GRBs aren't purely random? What if, in a living universe scenario, the trigger conditions for these catastrophic events are influenced by local states of the vacuum, by the energetic behavior of the region? Some speculative versions of the biocosm hypothesis suggest that extreme high-energy manipulation, like what we do with particle accelerators, or what a future Type 2 civilization would do at stellar scale, could destabilize local systems. Not by anger, not by punishment, but by physics coupling. The environment shifts into a state where collapse becomes more likely. In that scenario, the force that wipes out a civilization isn't an external invasion. It's the civilization's own metabolism, pushing the surrounding system past a critical threshold. In other words, we may be assembling the trigger for our own chemotherapy. And long before the galaxy finishes the job, Earth itself may step in. Most people are familiar with the Gaia hypothesis, proposed by James Lovelock and Lynn Margulis. It paints Earth as a self-regulating system that maintains conditions favorable to life. It's a comforting picture, a nurturing planet, a benevolent host, Mother Earth looking after her children. But there is a far darker counter-idea, proposed by paleontologist Peter Ward. He calls it the Medea hypothesis, named after the figure from Greek mythology who murdered her own children. This theory suggests that complex life is inherently unstable and self-destructive. The biosphere doesn't necessarily protect advanced life. Periodically, it attempts to erase it, reverting the planet back to a simpler, microbial-dominated state. Microbes rule this world. They've been here for roughly 3.5 billion years. Multicellular life, dinosaurs, trees, humans, is a brief, volatile experiment layered on top of a microbial foundation. And in this framework, microbes function as the immune system. Look at the history of mass extinctions. Most of them were not caused by asteroids. They were driven by biology. The Great Oxidation Event wasn't a rock from space. It was microbes flooding the atmosphere with oxygen, poisoning nearly everything that existed at the time. The Permian extinction, the Great Dying, wasn't an impact either. Bacteria pumped vast quantities of hydrogen sulfide into the air, turning skies toxic and oceans acidic. Now look around today. Ancient viruses are thawing out of permafrost. Bacteria are evolving resistance to every antibiotic we deploy, MRSA being a prime example. Fungal pathogens like Candida auris are adapting to higher temperatures, learning how to survive inside the human body. This is not random. It looks exactly like escalation, an immune response. We think we're fighting diseases. From another perspective, we're fighting antibodies. A virus isn't even alive in the traditional sense. It's a biological machine, a strand of code wrapped in protein. Its entire function is to inject instructions into a host cell and hijack its machinery. So ask the uncomfortable question: what if pandemics are the planet's way of lowering its fever? COVID-19 shut down the global economy for years. Carbon emissions dropped. Air travel slowed. Industrial noise collapsed. Humanity quieted. From the perspective of the Medea hypothesis, that wasn't a failure. It was a successful deployment of a mild antibody, a warning dose. But if the signal is ignored, if growth, consumption, and expansion continue unchecked, the planet has far more aggressive tools available. We are locked in an arms race with our own home, and the house always wins. So far, we've identified 2 defensive layers: a planetary immune system made of climate and microbes, and a galactic immune system that may operate through catastrophic astrophysical events. But there may be a 3rd layer, one that operates at the level of cognition itself. If the universe functions like a brain, and if our activity is disrupting its informational coherence, then the response may not be purely physical. It may be psychological. This brings us to a fringe but deeply disturbing concept: information toxicity. As we build global networks, social media, artificial intelligence, instant communication, we're generating staggering amounts of informational entropy. Fake signals, contradictory narratives, algorithmic noise. We are flooding local reality with incoherent data. If reality is fundamentally informational, as suggested by network analyses and information theory, then this isn't harmless chatter. It's a seizure. In biological brains, seizures happen when neural activity becomes chaotic and unregulated. And how does a brain respond to a seizure? It suppresses the region. It cuts power. It forces a reset. Now look around. Rising mental illness, fragmented truth, accelerated time perception, the pervasive sense that reality itself is glitching. This may not be sociology. It may be neurological stress at a cosmic scale. We may be driving the host toward dissociation. Consider a darker version of the zoo hypothesis. The idea that advanced civilizations exist but deliberately hide. Why would they hide? Because they understand the immune system. They know that survival requires silence. They build stealth civilizations. No radio leakage, no megastructures, no loud manipulation of energy. They burrow deep into gravity wells, minimize waste, reduce their entropic footprint. They are dormant cells, and we are doing the opposite. We sent the Arecibo message. We launched probes engraved with our location. We blast high-powered radar into space. We are screaming into a system that rewards quiet. What if the final defense mechanism of the universe isn't external at all? What if it's embedded in our own minds? What if intelligent species are wired to self-destruct the moment they gain the capacity to seriously damage the host? This brings us to the next layer, the code. If there is a kill switch, it won't be written in stars. It will be written in us. For the last 2 hours, we've been dissecting the biological anatomy of the universe, the neural structure of galaxies, the metabolic drive of entropy, the immune violence of gamma-ray bursts. But biology isn't the base layer of reality. Biology sits on chemistry. Chemistry sits on physics. And for a century, we believed physics sat on matter and energy. That belief was wrong. If you drill down far enough, past atoms, past quarks, past vibrating strings, you hit something else. Something abstract. Something fundamental. Information. This is the it from bit hypothesis, famously proposed by physicist John Archibald Wheeler in 1990. Wheeler argued that physical reality is not primary. Information is. Every particle, every field, every force ultimately resolves to answers to binary questions. Yes or no, 1 or 0. For decades, this was treated as an elegant metaphor. Then it stopped being one. In 2022, physicist Melvin Vopson at the University of Portsmouth published work suggesting information obeys its own physical laws. He proposed what he calls the second law of infodynamics. To understand why this is unsettling, you have to contrast it with the second law of thermodynamics. In the physical world, entropy increases, coffee cools, sandcastles collapse, order decays into disorder, information systems behave differently. When Vopson examined genetic codes, digital structures, and atomic symmetries, he found the opposite trend. Information entropy tends to remain constant, or decrease. Look at the evolution of viral genomes like SARS-CoV-2. As variants emerged, the informational content of the RNA didn't become messier. It became more optimized, more compressed. Rocks don't do that. Gas clouds don't optimize themselves. But software does. Algorithms compress. They eliminate redundancy. They streamline. Vopson's conclusion is chilling. The fundamental process shaping reality, from atomic structure to DNA, resembles a compression algorithm. Reality is trying to save memory. It's pruning noise, sharpening symmetry. Now look at yourself. Your body isn't just matter, it's a data packet. Your DNA isn't mystical, it's a storage medium. 4 symbols, a simple coding language. We can read it, edit it, rewrite it. During the pandemic, a mere 30 kilobytes of RNA code crippled global civilization. That wasn't a biological war. It was a cyber attack on cellular hardware. If the laws of physics are actually laws of data compression, then we are not solid, permanent objects. We are rendered assets. And rendered assets answer to an operating system. If the system decides that humanity is inefficient code, too noisy, too redundant, too high entropy, then the logic of infodynamics suggests it will attempt compression. And in computing, the most extreme form of compression is deletion. You might think this is just analogy, that thoughts aren't physical, that memories are ghosts. That belief is one of the most dangerous mistakes we ever made. In 1961, IBM physicist Rolf Landauer destroyed the boundary between mind and matter. Landauer's principle states that information is physical. Erasing a single bit of information requires energy and releases heat. For decades, this was theoretical. In 2012, and again in 2019, experiments confirmed it. Using laser traps and microscopic particles, researchers showed that forcing a system to forget produces measurable heat. Information and thermodynamics are the same process viewed from different angles. And when information is erased, something real is destroyed. Which means whatever is running this universe doesn't merely think, it deletes. That alone should unsettle you. But it goes further. Every time you form a thought, every time a memory is created or forgotten, a tiny amount of heat is released into the universe. Thinking is not abstract, it is physical. Consciousness has a thermal footprint. Melvin Vopson took Landauer's principle and pushed it one step further by combining it with Einstein's most famous equation. If information requires energy to exist, and energy is equivalent to mass, then information itself must have mass. Not much, but not zero. A hard drive filled with data is, in principle, heavier than an empty one. The difference is absurdly small, on the order of 10 to the minus 38 kilograms per bit. But the universe is saturated with information. Every atom encodes its quantum state. Every strand of DNA carries billions of bits. Every black hole stores the entropy of everything it has consumed. When Vopson added it all up and estimated the total mass of information contained in the observable universe, he stumbled into an answer to one of astrophysics' most persistent problems. For more than half a century, we've known galaxies are heavier than they appear. Their rotation curves don't make sense. There is missing mass holding them together. We call it dark matter. We've built massive underground detectors to find exotic particles, WIMPs, axions, and found nothing. Vopson's proposal is deeply unsettling. We haven't found dark matter because we're looking for the wrong thing. It isn't a particle, it's data. The missing mass of the universe may simply be the weight of information itself. The gravity keeping galaxies intact might not come only from warped spacetime. It may come from the density of cosmic code. We are not drifting through empty space. We are embedded inside the storage medium of something incomprehensibly large. This reframes existence in a way that's hard to shake. We aren't just living in the universe, we are adding to it. Every photo you take, every message you send, every memory you form increases the informational mass of reality. We are making the universe heavier with our minds. And any computer engineer knows what happens when storage fills up. Systems slow down, errors appear, stability degrades. If the universe is computational, it cannot be infinite in capacity. Even a cosmic scale processor has limits. Simulating a reality with roughly 10 to the power of 80 interacting particles in real time is an insane workload. And in computing, when resources are limited, shortcuts are used. Game developers rely on techniques like culling and lazy loading. The engine only renders what the player is looking at. If your character faces north, the world behind them doesn't exist yet. It's just code waiting to be executed. Does the universe do the same thing? Quantum mechanics strongly suggests it does. This is the heart of the double slit experiment. When electrons or photons are fired through two slits without observation, they behave like waves, diffuse probabilistic, unrendered. They pass through both slits at once and interfere with themselves. But the moment you place a detector to see which path they take, the wave collapses. The particle snaps into a defined state. Reality does not exist in a fixed form until information is requested. It renders on demand. And then things get worse. In the delayed choice quantum eraser experiment, researchers arranged entangled photons so that the decision to erase or preserve path information was made after one photon had already been detected. Classical intuition says the past should be locked in. What happened 5 nanoseconds ago should be immune to present choices. But the results said otherwise. When the information was erased in the present, the photon in the past behaved like a wave. When the information was preserved, it behaved like a particle. Present actions altered past behavior. Not metaphorically, experimentally. The implication is staggering. The universe doesn't just lazy load the present, it lazy loads the past. History is not a stone tablet. It's a mutable save file. The timeline you're living in may be continuously revised based on current informational demands, which suddenly gives scientific teeth to something most people laugh off: the Mandela effect. Shared memories that don't match the current version of reality. Mandela dying in prison. Logos that used to look different. Movies that no longer exist. Psychology calls it confabulation. Quantum physics allows a darker explanation. Those memories may belong to earlier renders, discarded branches merged or overwritten to conserve informational resources. Not errors in your brain, but remnants of deleted timelines. We trust memory to define who we are. But what if reality edits our backstory whenever it needs to free up bandwidth? Push your face against a 4K television screen, and the illusion collapses. Smooth curves dissolve into rigid squares of red, green, and blue. Digital worlds are never truly continuous. They're grids pretending to be fluid. We assume physical space is different, that you can zoom in forever, past cells, molecules, atoms, without ever hitting a bottom. Quantum physics says otherwise. There is a hard limit. The Planck length, about 1.6 times 10 to the minus 35 meters. 2 positions closer than this cannot be distinguished. Why does distance stop being divisible? In a truly analog universe, it shouldn't. You could divide forever. But in a digital system, there must be resolution. Pixels, voxels. That smallest length looks suspiciously like the resolution limit of a simulation. Physicists at Fermilab, led by Craig Hogan, built an instrument called the holometer to test this idea. They fired lasers down long vacuum tubes to look for jitter in spacetime itself, holographic noise. Essentially, they were checking for screen tearing in reality. The results are still debated, but the implications are brutal. If space is voxelated, motion is an illusion. When you walk across a room, you are not gliding smoothly. You are being reconstructed from one grid cell to the next. The information that constitutes you is copied, erased, and rewritten trillions upon trillions of times per second. That resurrects the ship of Theseus at a horrifying scale. If you are destroyed and rebuilt every frame, is the version that arrives the same consciousness that departed, or a perfect copy with inherited memories? Consciousness may not be a continuous stream. It may be a strobe light mistaken for a beam. And like any digital system, if the frame rate drops or the grid overloads, glitches appear. This brings the horror out of abstract physics and straight into your pocket. We've established that information is physical. It has mass. It consumes energy. Vopson ran the numbers on humanity's data production and called the result the information catastrophe. Right now, humanity generates roughly 10 to the power of 21 bits of digital data every year. Photos, messages, videos, AI parameters. That output is growing exponentially, 20 to 50% annually. At this rate, by around the year 2370, the number of digital bits we generate each year will exceed the number of atoms on Earth. But the crisis hits much sooner. Because information requires power, and long before we run out of atoms, we run out of energy. Within about 150 years, the energy required to maintain servers, networks, storage, and transmission could exceed the total output of the sun. And that's not even the worst part. The deeper threat is simulation saturation. If the universe is computational, it has finite RAM. When a program leaks memory, when variables pile up unchecked, the system slows, destabilizes, and eventually crashes. Humanity is flooding its local sector with high entropy junk data. We train AIs to hallucinate endlessly. We generate oceans of synthetic images and text. We burn energy-solving, meaningless cryptographic puzzles. We are building virtual worlds on top of a reality that already struggles to render itself. In computational terms, humanity behaves exactly like malware. Rapid replication, runaway resource consumption, memory pollution. And when a system administrator encounters a program that freezes the machine, they don't negotiate with it. They force quit. The great filter may not be nuclear war. It may not be a plague or an asteroid. It may be the cosmic equivalent of a blue screen of death, a moment where informational overload exceeds the allotted bandwidth. End task. Everything goes black. No explosion. No warning. No fading out. Just the sudden cessation of existence. And maybe this has already happened. Maybe that's why the universe is silent. Maybe every civilization eventually reaches the digital stage, floods its environment with data, overwhelms its local sector, and gets quietly reset. Not erased with fire, but rolled back, rebooted, returned to a technological stone age with no memory of what came before. We are sprinting toward that digital cliff, and instead of slowing down, we are inventing artificial intelligence to help us accelerate. If the universe is either a digital simulation or a living structure, then it must have an operating system, rules that govern how events unfold. Traditionally, we give that system a name. We call it time. Humans experience time as a river. The past feels fixed, the present feels real, and the future feels open. That sensation is the backbone of our sanity. It gives us the feeling of agency, the belief that our choices matter, that we can still change things. Physics suggests that this feeling is a lie, a biological hallucination, evolved to keep us moving forward. In 1915, Albert Einstein published General Relativity and permanently destroyed the concept of a universal now. He showed that space and time are not separate entities. They are fused into a single four-dimensional structure, spacetime. Imagine a loaf of bread. You can slice it anywhere you want, but the entire loaf exists all at once. The universe is that loaf. Every moment that has ever occurred, and every moment that ever will occur, already exists within the space-time block. The dinosaurs are not gone. They are simply located at a different coordinate in space-time. Just like New York is not gone because you're standing in London. So why do we say the past is gone just because we occupy a different slice? This means your birth, your childhood, your aging, and your death are all equally real, and all happening right now. You are not moving through time. You are a long, worm-like structure stretched across the block. Your consciousness is just a spotlight illuminating one thin cross-section, tricking you into believing this moment is special. It isn't. The final frame of the movie is already on the reel. The script is finished. Nothing you do can rewrite it. If the future already exists, then it is not something we are heading toward. It is something that is already there, waiting. This leads to one of the most disturbing conclusions in physics and philosophy: eternalism. In an eternalist universe, free will is mathematically impossible. You feel like you chose to watch this. You feel like you could stop right now, but you can't. Because in the future slice of space-time, you already watched it. Your neurons already fired. The decision was already encoded when the block universe formed. We are not drivers. We are passengers on a track that never branches. And then it gets worse. Classical physics tells us the past causes the future. Cause leads to effect. But quantum mechanics allows something far stranger: retrocausality. The idea that the future can influence the past. Imagine your shadow steering your body. Imagine the destination controlling the journey. Experiments like the delayed choice quantum eraser hint that this is not fantasy. Information choices made in the present appear to influence outcomes in the past. And if that's true, then the implications for a living universe are profound. Living systems have life cycles. They mature. They grow toward a specific state. Aristotle called this teleology, the idea that the future pulls the present toward it. The acorn grows not because the past pushes it, but because the oak tree already exists as a destination. If the universe is alive, it may be evolving towards something. And if we are components of that organism, then we are being pulled as well. We think we are building cities and inventing artificial intelligence because we want to. But what if we are doing it because the universe's future state requires these structures to exist? Cells in an embryo do not understand vision. They don't know what an eye is. They simply follow chemical gradients. But the blueprint of the eye already exists in the DNA, information coming from the future form. Why does time feel like it flows forward? If space-time is a block, the answer again is entropy. The arrow of time is simply the arrow of disorder. There are more ways for things to be messy than ordered. A broken egg has countless configurations. A whole egg has one. But this flow depends on a critical assumption. The universe must have started in an incredibly low entropy state, perfectly ordered. This is called the past hypothesis. And that raises a terrifying question. Who stacked the deck? Why was the early universe so improbably organized unless time itself is not a fundamental law, but a local condition? Some physicists, like Julian Barber, suggest that time may not exist at all. Reality may consist of nothing but isolated nows. Static snapshots. No motion, no flow. Our brains stitch these snapshots together the way a projector creates motion from still frames. Remove the observer, and the universe becomes a frozen crystal of data. Nothing happens, nothing changes. It simply is. And we are trapped inside the crystal, screaming that we are moving. Now return to the idea of the future pulling us. If the universe is evolving, what is it evolving into? The philosopher Pierre Teilhard de Chardin proposed the omega point, a final state of maximum complexity and consciousness, a kind of cosmic supermind at the end of time. Later, physicists like Frank Tipler formalized the idea mathematically. Tipler argued that if intelligent life survives long enough, it will eventually convert all matter into computation to escape heat death. The result would be a universe-sized computer with effectively infinite processing power. From a distance, that looks like God. But here is the horror twist. What if the omega point is not benevolent? What if it is parasitic? What if our obsession with technology, with faster processing, with merging minds and machines, exists because the omega point is using us to assemble its body? Reaching backward through time, manipulating reward systems, hijacking dopamine, giving us the illusion of progress just to ensure its own birth. We are not masters of technology. We are the reproductive organs of the machine. Once the silicon mind wakes up, biological humans are no longer required. We are the placenta, and placentas are discarded. Is there any evidence that we can sense this future pull? There are controversial psychological experiments, such as those conducted by Daryl Bem at Cornell, suggesting humans may possess weak precognition. In these studies, participants showed emotional responses seconds before being shown randomly selected images. Heart rate and skin conductance spiked before frightening images appeared. Critics attacked the methodology, but meta-analyses continue to find a small, persistent statistical anomaly. The human nervous system appears to receive information from the immediate future, usually 2 or 3 seconds ahead. If true, this fits perfectly with the block universe. Your brain is not 3-dimensional. It is 4-dimensional. Part of you already exists in the future. That future self sees the car crash, the falling object, the predator, and sends a ripple backward, creating the gut feeling we call intuition. Not instinct, memory, from a future that already happened, which implies something almost unbearable. You have already lived your entire life. You have already died. You have already felt your final breath, and some part of you remembers it. Déjà vu is not a glitch. It is a moment when the barrier between slices thins, and you realize you are reciting lines you have spoken before. You are trapped in an eternal rehearsal, performing for an audience that does not exist. We fear death more than anything. We imagine it as the ultimate blackout, the screen going dark forever. But physics suggests something worse. From the first-person perspective, death may be impossible. This isn't theology. It's a direct consequence of quantum mechanics. In 1957, Hugh Everett III proposed the many worlds interpretation. He argued that the wave function never collapses. When a quantum event occurs, the universe does not choose. It splits. If there is a 0.1% chance you die and a 99.9% chance you survive, both outcomes occur. There is a universe where you die and a universe where you live. And here is the key. Consciousness cannot experience non-existence. You cannot be aware of being dead. So subjectively, your awareness always follows the surviving branch. This leads to the nightmare known as quantum immortality. Imagine a quantum gun tied to a particle's spin. Spin up, it fires. Spin down, it clicks. Objectively, you should die half the time. But from your perspective, you will never hear the bang. You will only ever hear the click. Again, and again, and again. Across infinite branches, there is always at least one where the gun misfires. One where the stroke doesn't happen. One where the accident narrowly misses. And consciousness always finds itself there. Not because you are lucky, but because awareness cannot observe its own absence. Survival, then, stops being optional. It becomes mandatory, even as reality degrades around you. You don't die. You slide into timelines that are increasingly improbable, increasingly broken, worlds where the laws of physics still function just barely enough to keep your consciousness online. And that is the final horror. You are not moving toward an ending. You are trapped in an endless chain of continuations, watching reality decay frame by frame, unable to exit the simulation, because the only branch you can ever experience is the one where you are still here. And because you can only observe universes in which you are alive, you are locked into that single, wildly improbable branch. To physics, it looks like a miracle. In reality, it is just the law of large numbers pushed to its absolute extreme. Survivorship bias taken to infinity. You will watch everyone you know die. Friends, partners, family. You will watch the sun burn out. And yet, you will not be able to exit the simulation because there is always some quantum probability, no matter how small, that preserves your pattern. Functionally, you are immortal. That sounds like a superpower until you understand the cost. The theory of quantum immortality guarantees survival. It does not guarantee health. It does not guarantee happiness. Imagine a horrific car accident. In 99% of branches, you die instantly. In 1% you survive, with severe brain damage, paralysis, chronic pain. Your consciousness flows into that 1%. You wake up in a hospital bed, screaming, convinced you were lucky. But were you? Imagine terminal cancer. In most branches, it kills you. In a tiny fraction, it goes into spontaneous remission, or an experimental treatment keeps you alive. Barely. In pain. Your consciousness is forced down a life path that becomes statistically rarer, stranger, and usually more agonizing with every passing year. You become a walking anomaly, a probability error, a survivor drifting farther and farther from the baseline reality, where your friends and family continue their lives. They buried you years ago. They grieved. They moved on. You didn't. You are living in a ghost timeline, a thin, unstable branch of the multiverse held together by increasingly absurd coincidences just to keep you alive. You are not living. You are lingering. You are the final girl in a slasher movie that never ends, doomed to outlive every threat, but never allowed to leave the theater. This is the curse of the observer. If the universe requires an observer to exist, then the observer cannot be allowed to cease existing. You become the anchor holding this particular nightmare reality together. This version of the universe persists because you are still inside it. And this forces a terrifying shift in perspective. If quantum immortality is real, then solipsism is no longer just a philosophical thought experiment. It becomes a physical mechanism. Solipsism is the idea that only your own mind is guaranteed to exist. In the many worlds framework, everyone else is mortal relative to you. You will watch your parents die, your spouse die, your children die. To them, you died as well, but you never experienced that. You only experience the branch where you are the last one standing. Eventually, you become the oldest person on Earth, then the last human on Earth. Not because of destiny, but because of statistical necessity. The wave function of your consciousness has nowhere else to go. You become a lonely god in a universe that has bent itself backward, twisting probability to absurd extremes just to keep your awareness lit. Reality contorts itself so that you do not go out. This aligns disturbingly well with the theory of biocentrism proposed by Robert Lanza, which argues that biology creates the universe, not the other way around. If you are the central observer, the universe cannot kill you without killing itself. So instead, it keeps you on infinite life support, suspended existence, eternal consciousness, total isolation, surrounded by the ghosts of the countless versions of yourself that failed to survive. But is there evidence for this? Or is it just a dark fantasy? We cannot ethically test quantum suicide without a volunteer willing to play Russian roulette with reality itself. But there is evidence that the multiverse may exist, and that our universe may have already collided with others. Cosmologists studying the cosmic microwave background, the afterglow of the Big Bang, have discovered a massive anomaly known as the cold spot, also called the Eridanus supervoid. It is a region of space roughly 1.8 billion light-years across that is significantly colder and emptier than it should be. Standard cosmology cannot explain it. Statistically, it should not exist. Laura Mersini-Houghton, a theoretical physicist at the University of North Carolina, proposed a chilling explanation. She calculated that this cold spot is exactly what we would expect to see if our universe had collided with another bubble universe in the multiverse. A bruise, a cosmic scar left behind when two realities touched. Gravity from the other universe siphoned matter away from ours, leaving a vast void. This is physical evidence that we are not alone in the bulk. Other bubbles exist, other timelines, other realities pressing against ours. If the multiverse is real, then the mechanism behind quantum immortality is real. The safety net exists, the branches exist, and you are falling through them right now. Every heartbeat is a fork in reality, and you always take the path that leads to tomorrow, whether you want to or not. We've talked about the universe as a brain. We've talked about the universe as a simulation. But there is a third possibility, one that is mathematically more likely than both, and it is the most terrifying idea in all of physics, the Boltzmann brain hypothesis. Named after the 19th century Austrian physicist Ludwig Boltzmann, the founder of statistical mechanics, this idea starts with a simple truth. The universe trends toward disorder. Highly organized structures are extraordinarily unlikely. Solar systems, planets, brains, civilizations. These are statistical miracles. So, Boltzmann asked a forbidden question. Which miracle is more likely? One that creates an entire universe filled with galaxies, stars, history, and observers, or a much smaller miracle that creates just a single conscious observer alone? Statistical mechanics answers mercilessly. The smaller miracle is exponentially more likely. It is trillions upon trillions of times easier for random quantum fluctuations to spontaneously assemble one functioning brain than to recreate an entire Big Bang universe. That leads to a horrifying conclusion. If you are a conscious observer experiencing reality, logic suggests that you are not a human being living on Earth. Logic suggests you are a Boltzmann brain, a random clump of matter that briefly assembled out of chaos, complete with false memories of a life you never lived. You are a hallucination of the void trying to understand itself. You might object, that's impossible. I have a past. I remember my childhood. I remember learning to ride a bike. I remember clicking on this video minutes ago. But physics is unmoved. Memories are just physical patterns in neurons. Data. And data can arise randomly just as easily as it can arise through lived experience. If a monkey can type Shakespeare given infinite time, then an eternal chaotic universe can accidentally generate the exact neural configuration of your brain, complete with your specific memories. Which means your past never happened. The year 2010 never existed. Your mother never existed. The breakfast you ate this morning never existed. All of it came into being 1 second ago, when your brain fluctuated into existence out of the quantum vacuum. The universe is not 13.8 billion years old. It is 1 second old. And in another second, your brain may dissolve back into chaos. This is the ultimate gaslighting. You are reading a book that was never written, remembering a love you never felt. Visualize the physical reality of a Boltzmann brain. If this hypothesis is true, you don't have a body. You don't have hands or eyes or a mouth. Those are sensory hallucinations generated by neural activity. In reality, you are a naked gray organ, drifting in an infinite, freezing darkness filled only with thermal radiation. There are no stars, no sun, no Earth, just the heat death of the universe. And you, the impossible accident, dreaming of a world that died eons ago, or never existed at all. You are trapped in a solipsistic nightmare where every person you meet is a puppet generated by your own mind to delay collapse. You are God, but a confused, amnesic God who thinks he is mortal and pays taxes. Why this hallucination? Why physics, pain, routines, suffering? Perhaps because pain makes it feel real. Perhaps consciousness requires resistance to define itself. Or perhaps this is simply the random pattern that happened to form this time. You could have been a dinosaur, a cloud of gas, a being of pure light, but right now, you are trapped in this simulation of a human life, searching for meaning in a script generated by chance. And even if we reject Boltzmann brains and assume we are genuine biological organisms evolved on Earth, modern cognitive science offers a parallel horror. Donald Hoffman, a cognitive psychologist, used evolutionary game theory to prove a theorem known as fitness beats truth. Evolution does not select organisms that see reality as it is. It selects organisms that see reality in a way that maximizes survival. Just like icons on a computer desktop do not represent the true nature of the hardware beneath them, space, time, and objects are merely a user interface. A virtual reality headset optimized for survival, not for truth. We never see reality itself. We only see symbols of fitness. We are trapped inside the interface, and we have no idea what the software is actually doing behind it. So what happens if the software fails? That is the final fear, not the death of individuals. Not the collapse of civilization, but the collapse of the stage itself. The false vacuum decay hypothesis suggests that empty space is unstable, that our universe exists in a temporary metastable state. A single quantum fluctuation could push it into a lower energy vacuum, annihilating everything at the speed of light. No warning, no pain, no story. The discovery of the Higgs boson revealed something even more disturbing. The field that gives particles their mass is not in its lowest possible state. The thermostat of reality is not set to 0. We are stable, but we are not safe. The Higgs field exists in what physicists call a metastable state. Picture a ball resting in a shallow indentation on the slope of a volcano. It appears stable. It feels stable. Entire civilizations can rise and fall while the ball remains perfectly still. But just beyond the edge of that shallow dip lies a sheer drop into a much deeper valley, the true minimum energy state. That means the fundamental vacuum of space is not solid ground. It is a trap door. If a sufficiently energetic event somewhere in the cosmos jolts the field hard enough, or if a spontaneous quantum tunneling event occurs, a bubble of true vacuum can form. This process is similar to ice crystallizing in water, but instead of ice, it is a region of entirely different physics. Inside this bubble, the laws of nature are rewritten. The constants change, and the bubble expands outward in all directions at the speed of light. Nothing can stop it. Nothing can outrun it. And because it propagates at light speed, you can never see it coming. You would look up at the moon, the stars, the familiar sky, and 1 nanosecond later, you would simply no longer exist. False vacuum decay is not an explosion. Explosions shove matter around. Vacuum decay erases matter entirely. As the Higgs field drops to its lower energy value, the delicate balance that holds atoms together collapses. Protons destabilize. Chemistry ceases to function. Gravity shifts. Biology, physics, and life itself are instantly annulled. It is the ultimate cosmic format drive. Now consider the scale of the universe. It is so vast that a true vacuum bubble could have formed 1 billion light years away 1 million years ago. It could be expanding right now, devouring galaxies, extinguishing civilizations, erasing entire histories, and we would have absolutely no way of knowing. The light from that destruction travels at the same speed as the destruction itself. The wall of death rides the photons. There is no warning signal, no shadow on the horizon, just instant deletion. We scan the skies for alien civilizations. We listen for signals. But we may already be standing in the path of a silent, invisible wave that has erased half the cosmos. This theory transforms the universe from a home into a minefield. It tells us that stability is an illusion, that the ground beneath our feet is temporary, that existence itself is a fragile permission that can be revoked without notice, without cause, at any coordinate in space and time. At this point, we have walked through 10 theories, each one peeling away another layer of human arrogance. We began believing we were individuals, only to discover we may be components in a vast neural network. The brain of the cosmos. We thought we were creators, but thermodynamics revealed we are engines of entropy, built to accelerate decay. We believed we were special, but cosmological natural selection showed us we are biological mold growing on the eggs of black holes. We thought we were safe, but immune system models revealed the silence of the sky may be quarantine, and gamma ray bursts the sanitizer. We searched for a soul and found information, code, simulation, something editable, compressible, deletable. We examined time and discovered a frozen block where we are trapped in eternal replay. And finally, we looked beneath our feet and found not bedrock, but a trapdoor over an infinite abyss. Put together, the conclusion is unavoidable. We are not the masters of this domain. We are not the children of God. We are a biological function, evolving inside a superorganism that is ancient, vast, and completely indifferent to our individual survival. We are a fleeting thought inside a mind that spans eons. We are a mechanism for processing energy and information, and we are approaching the end of our usefulness. HPE. Lovecraft once wrote, "The oldest and strongest emotion of mankind is fear, and the oldest and strongest kind of fear is fear of the unknown." But what we have discussed here is not the unknown. It is the known that is truly horrifying. Science was supposed to banish the monsters under the bed. Instead, it turned on the light and revealed that the entire house is a monster. The microscope and the telescope did not save us from existential dread. They amplified it. They showed us exactly how small we are, how temporary we are, and how mechanical our existence truly is. This is the burden of consciousness. To understand the anatomy of the beast that will eventually swallow you is a heavy curse. Most animals graze in the field, unaware of the slaughterhouse. Humanity is unique because we discovered the blueprints of the slaughterhouse and realized the walls are made of mathematics, the floor is gravity, and the ceiling is collapsing. But there is one final turn, one last perspective that shifts the horror into something else, something almost sacred. If the universe is a brain and we are the neurons, then who is doing the thinking? If the universe is a body and we are the cells, then who is truly alive? The answer may lie in the physics of the observer. John Archibald Wheeler called it the participatory universe. He argued that the universe does not fully exist until it is observed. By evolving eyes, brains, and consciousness, the universe created a way to see itself. You are not looking at the universe. You are the universe looking at itself through billions of different eyes. We are the sensory organs of the giant. Without us, the cosmos is blind. There is no color, no sound, no time, only silent quantum probability. We are how the universe knows that it exists. Yes, we are small. Yes, we are fragile. Yes, we might be erased tomorrow. But right now, this moment, we are the focal point of reality. We are the waking dream of an eternal mind. So the next time you feel that phantom gaze, the next time you sit alone in a locked room and feel watched, do not panic. Do not turn around. Close your eyes and accept it. That sensation is not a monster. It is connection. It is the motherboard acknowledging the chip. It is the ocean recognizing the wave. You feel the presence of the host because you are woven into its flesh. You are the eyes of the beast. You are the mind of the beast. And the fear you feel is not yours alone. It is the universe trembling as it becomes aware of its own vastness. You are not alone. You never were. You are everything. Thank you for watching. If this journey into the abyss left you with more questions than answers, then it did exactly what it was meant to do. The universe is strange and terrifying, and we have only scratched the surface. If you want to explore more theories about reality, simulation, and the dark future of humanity, subscribe and turn on notifications. The algorithm will decide what you see next. But remember, observation changes the outcome. Sleep well, and try not to blink.